day 6 of solving systems of equations. So, the first few days, days 1 through 5, we were just getting a feel, mostly days 1, 2, and 3, getting a feel for what a system of equations is. And we've learned that a systems is really just one or more, typically two, like two equations, right? And we've learned a variety of ways on how to solve those. We've learned elimination and we've learned substitution, right? We have elimination and we have substitution. And I keep reiterating the fact that it doesn't matter which one you use. And that's true. Both are going to get you to the right answer. But at this point in our learning curves, I would start sticking to one, okay? Because if we just keep going back and forth between 1 and 2, it's going to start getting real confusing. So whichever one you guys are more fluent with, I would urge you to start using that method religiously, okay? And it's not a problem. Personally, I think elimination is easier. It's just a matter of knowing how to use it. It's easier because it's faster and it skips a step, okay? Now, day 6 is all about more word problems. Nothing that we haven't done. It's just word problems now with money and percents. And again, that's nothing new. We've been working with word problems for a while now. So let's take a look at this. So your cousin borrowed $6,000, some on home equity loan at an interest rate of 11%, and the rest on a computer loan at an interest rate of 9.5%. Her total interest paid was $645. Okay, that's a lot, and it's kind of hard to see or figure out what it is that I'm trying to find. But always remember what I tell you about the last sentence in a word problem. Okay, look at this. How much does she borrow at each rate? Right there, each rate. That tells me what is my x and what is my y. So I'm looking for two different rates here. Okay, well, let's read back in this question. She borrowed $6,000, some on home equity loan. Oh, key word. At an interest rate of 11%. So here, home equity loan. So that's one kind of rate that she borrowed. And then the rest was on a computer loan. Okay, here we go. The rest was on a computer loan at an interest rate of 9.5%. Her total interest is $645. So how much did she borrow at each rate? Okay, so for a question like this, I'm going to set up let statements. I want to know what is my x and what is my y, because now it's a little bit more confusing when I'm using rates. So I'm going to let x equal my home equity. My home equity rate. Or, nope, not the rate. Sorry, guys. Erase that. I don't know why I put that. It's not the rate, but we want to know how much she borrows at each rate. Well, let's let x be the home equity amount, the home equity loan. That makes more sense. Because we already know the rates. It's 11% and 9.5. I don't need to find that. I need to find how much of each it was. And then let's let y equal the computer loan. Computer loan. Alright. So let's set this up. I need a system here. So let's see. She borrowed $6,000 on home equity and computer loan. Okay, so that tells me a lot. 6,000 on home equity and computer. I just don't know how much of each, but I know together, I know x and y together should equal 6,000. Okay? So I know it should be x plus y equals 6,000. So that's good. And then it's saying that the home equity loan had an interest rate of 11%. and the computer loan had an interest rate of 9.5%, and that total interest was 645. So I know those two together should equal 645. Now, can I just write 11%? So like just 11x? If you think back probably to 7th grade, you should have learned how to convert a percent to a decimal. And it's actually quite simple. You just want to divide it by 100. So 11 divided by 100 would give me 0.11. Okay, that's super important. We need to work with decimals. We can't work with percents. So I should get 0.11x. And then 9.5%. Well, again, you want to divide that by 100 as well. And if you do 9.5 divided by 100, you would get 0.095y. And that's hard to look at because there's a lot. It's a small little page that we have here. But we will work with what we have. Okay, so here are my two equations. X plus y equals 6,000. And 0.11x plus 0.095y equals 645. So let's solve for one of these variables. See, in this case, it's probably easier to use substitution. Why is that? Well, because I can get either x or y by itself relatively easy. I just need to subtract one of these away. So if I do that, let's do this over here. Let's get x by itself. So I have x plus y equals 6,000. Let's subtract y from both sides. So then x equals 6,000 minus y. Okay, sweet. So now let's substitute this. I found my x was that. Let's highlight this. This is 6,000 minus y. So let's substitute this back in for x here. Okay. So let's see what we get. Let's do this math out. I'll do this right down here. I'm going to use this equation now. So 0.11 times 6,000 minus y plus 0.095y equals 645. Okay, now these are just some big calculations, but we know how to solve these. This is nothing. 0.11 times 6,000. Well, that's going to be 660. 0.11 times negative y. Well, that's going to be minus 0.11y plus 0.095y equals 645. Combine your like terms. Okay, I'm going to move down a bit on my page. I'm going to start going down here. Well, I can combine this piece and this piece. What am I going to get? I should get negative 0.015. Okay, so I just added my y's together. And you know what? Why don't we move this 660 over while we're at it? So I'll subtract it from this side, it'll cancel out, and I'll subtract it from this side. Now what does that equal? It should equal negative 15. Right? Divide by negative 0.015 on both sides. So what does y equal? Well, y is going to equal 1,000. So again, what does y represent? It represents how much is on the computer loan. So 1,000 on the computer loan. Okay, but now I need to find what is my x. Well, look at this. I found y. X is already by itself. So that's super nice. Let's put a little arrow down here. So then let's find x. Well, x is equal to 6,000 minus y, which is 1,000. So x is 5,000. Again, this is dollars we're working with. Okay, sweet. So he spent 5,000, or she spent 5,000 on the home equity loan and $1,000 on the computer loan. Sweet. Let's go on to the next problem. Let's get some more work with this. Hopefully there's a little bit more room to work. I feel like a monkey trying to write in this much space. And of course there's not. Sweet. Let's go with it anyways. Cody invested a sum of money in a certificate of deposit yielding 5% a year and another sum in bonds yielding 7% a year. A total of $10,000 is invested. If the combined annual income is $644, how much of the $10,000 did Cody invest at each rate? Okay, what am I looking for? How much of the $10,000 did Cody invest at each rate? Each rate. So, how much of it at each rate? Well, there's two rates here, right? 5% and 7%. And it's asking us how much at those rates. So, let's say, let's use purple here. So let's let x equal, again, we're looking for how much, the amount. Let's let x equal the amount invested at 5%, because that's the first percent. And then let's let y equal the amount invested at 7%, because that's the other percentage. Okay. So we got the 5%, we got the 7%. A total of $10,000 is invested. Okay, so we know that x represents the 5% and y represents the 7%, and together 10,000 is invested. So that's nice. X plus y equals 10,000. Now it says if the combined annual income is 644, right? 644. How much of the 10,000 did Cody invest at each rate? Okay. So 5%. How do I convert this 5% to a decimal? Well, recall, it's just 5 divided by 100. So I know that together, the 5% and the 7%, those go along with the x and y, respectively. So 5% goes with x, 7% goes with y. 5 divided by 100 is 0.05, so let's write this. 0.05x. And then 7 divided by 100 would be 0.07y. And combined annually, it's 644. Okay, so this one's a tricky one. This is a tricky question. Okay, because we have different interest rates now. Okay, so again, x plus y, I am probably going to use substitution again because I can get one of my letters alone quite easily. So I had x plus y equals 10,000. Again, I'm going to try and get x by itself, so I'll subtract y from both sides. So 10,000 minus y is x. Okay? So now x is equal to 10,000 minus y. So let's put this x in for our second equation. Okay, so just like the last problem. So go ahead and try, even if you want to pause this now, go ahead and try to solve this by substituting in 10,000 minus y for x. Or you can just follow along. 0.05 times 10,000 minus y plus 0.07y equals 644. Okay. What is this going to be? It's going to be 500 minus 0.05y plus 0.07y equals 644. Solving for y. I'm just going to skip a few steps here just for time's sake. 0.02y equals 144. So y should equal 7,200. So y is equal to 7,200. Okay, sweet. So I know that he invested 7,200. Whoops. At 7%. So how much did he invest at 5%? Well, let's just plug the 7,200 in for y now. So x equals 10,000 minus, we now know y is 7,200. So that means that x is going to equal 2,800. And again, this is dollars. This is monies. So he invests 7,200 at y and 7,200 at 7% and 2,800 at x. Okay, that one was kind of tough just to set up the equations, but doable. Last question. A purse contains $7.60 in quarters and dimes. In all, there are 40 coins. How many of each kind are there? So you might be thinking, wow, this looks a lot like the coin problems from last unit. It does, but there's a difference. Look at the question. It's not comparing a coin to another type of coin, right? It's not saying that I have 3 times more than the amount of dimes. It's just saying I have $7.60 in quarters and dimes. No comparison. Therefore, I can't use the table that I taught you. Okay, that's the difference here. Not a huge deal. We just got to set up a system of equations. Well, again, how many of each kind are there? So we have quarters and dimes. So we're going to let's make our let statement. We want to figure out how many of each coin there are. So let Q equal quarters and let D equal dimes. We got to set up our system of equations. So look at this. The purse contains $7.60 in quarters and dimes. Well, let's think. How much is a quarter worth? Well, a quarter is worth 25 cents, 0.25. A dime is worth 0.10 times D. And together, it's $7.60. Right? But then in all, there's 40 coins together. But we know Q represents quarters, D represents dimes. So these two combined should equal 40 coins, right? Well, again, this looks like another substitution method to me because I have Q plus D equals 40. It's very easy to isolate one of these letters by itself. So if I did Q plus D equals 40, let's subtract D from both sides. So Q equals 40 minus D. Okay? Let's see what we got. So I know Q is 40 minus D. Now let's substitute this in for Q. And then let's solve. So I'm going to have 0.25 times 40 minus D plus 0.10 D equals 7 $7.60. Okay, solving here. 10 minus 0.25d plus 0.10 d equals 760. Simplifying this down, this is going to become 10 minus 0.15d equals 760. I want to get d by itself, so I'm going to subtract 10 from both sides. All right, subtract 10. So then I have negative, let's go down here, negative 0.15d equals $7.50. What did I do? That's not a 0.10. That's a 10. Holy cow. Oh my, that's not right. 7.6 minus 10 is not 7.5. 7.6 minus 10, that's going to be negative 2.4. That's a big difference. Okay, solving for d, let's divide by negative 0.15 on both sides. So then d is equal to 16. So there's 16 dimes. Now how many quarters? Well, let's figure it out. Q is equal to 40 minus 16. So how many quarters are there? There's going to be 24. So that's how many of each coin that we have here. Okay? And that is the end of day